Mrs. Miller's Math Show. So this is the one where you guys are going to pick. All right, ready? Are you guys ready? Today we are using equations. Woo! I know. So awesome. Okay, so everybody say hello to my lovely co-host, Crystal.
Don't be
All right. So here we go. Crystal has a very important job. She always tells you all what you win. Give her a round of applause. All right, so here we go. Here we go. So today, we've been practicing solving equations for x. Now, if we're using them, can anybody guess how we're going to be using them? To solve more equations, okay? Zach, what do you think? Okay, using them in what way? What is one of your favorite things to do in math?
Nothing.
For our viewers at home, Tyler will have a consequence. No, I'm just kidding. Okay, okay, fractions, right? You love fractions? Yeah. What's another thing that you guys love in math?
Easy problem.
Note the sarcasm. There's sarcasm involved. That's good. Word problems. Round of applause for that. We're doing word problems today.
The best kind of problems.
So, to get to the word problems, we need to review a couple of pieces of terminology. The first one is consecutive integers. Okay. So let's talk about the word consecutive first. Integer is a fancy word for number. Everybody give Esme a round of applause. Esme just okay. So integer is a fancy word for number. Consecutive. What does consecutive mean? Olivia? Good. Good. Things that, everybody give Olivia a round of applause. Olivia's explanation was perfect. So she said, right next to each other. So consecutive integers are integers or numbers that are right next to each other. So that are right next to each other. So, can somebody give me an example of some numbers that are right next to each other? And don't overcomplicate it. This is not a complicated question. Shuggy?
3 and 4.
3 and 4. Okay, if I continue that list, are there any others in the list that I could add?
5.
Okay, ladies, focus, focus. What?
5.
5 and 6 and 7. And we can continue on and on and on. We can also go down the other direction, right? So, clap if you agree. Everybody paying attention? Clap if you agree. I'm glad some people are clapping already. I haven't said anything yet. So, okay. Okay, clap if you agree that to get from the number 3 to the number 4, you have to add 1. Okay.
There's not enough people clapping.
I know. Some of us in the audience do not agree that to get from 3 to 4, you add 1. Okay, how about to get from 4 to 5? Clap if you agree that you have to add 1 to get... That's good. Okay, and on and on and on. Okay, so keep that in your mind. We're going to use that in just a little bit. Okay, let's move on, though, to a different type of consecutive number, and that is consecutive even integers. Consecutive even integers. By the way, while our audience is writing down what we're doing here, I want to make a note that on our test, so I'm putting this on camera now, on the first chapter test, this class was, honestly, I actually started thinking about this, the only class that I have ever had in the last 6 years of teaching where nobody got less than a C. That is amazing. Yay! And so that includes the honors Algebra 2 kids. So that's pretty good. That's very good. You are the elite. You guys did awesome. And the average, we said, remember, was 89%. That's so awesome. All right. Next, so let's get back to this. Consecutive even integers. So can somebody tell me what consecutive even, or give me an example of some consecutive even integers? What do you think? Jonathan?
2, 4, 6, 8.
Perfect. 2, 4, 6, 8. Clap if you agree with Jonathan. Yay.
Good job, Jonathan.
Clap if you disagree with Jonathan.
I'm just kidding.
Clap if you're not paying attention. Oh, viewers at home. Oh, no. Okay, so now here we go. Oh, that's good. Good comeback. Okay, so here we go. To get from the number 2 to the number 4, clap if you agree that you have to add 1. Okay, to get from the number 2 to the number 4, clap if you agree you have to add 2. That's good. Okay, good. Okay, so again, we're going to continue on. We'll come back to this adding stuff in a little bit. Can anybody guess what we're going to be doing next if we've done... Okay, Cole, what do you think?
Odd integers.
Good. Consecutive odd integers. Clap if you agree with Cole. All right. So here we go. Who can give me a list of consecutive odd integers? Tyler.
Oh, wait. 3, 5, 7, 9.
3, 5, 7, 9. Good. Clap if you agree with Tyler.
I'm not clapping.
You better be clapping. You better be clapping.
Clap if you disagree with Tyler. Clap if you didn't clap for either of those last two options.
I was
You were writing. Okay, good. All right, so here we go. To get from one integer to the next, we have to add how many? 2. Good. 2, 2, 2. Okay, so here's what we're going to do. In some of our word problems today, we're going to be solving for missing consecutive integers. So whenever we're solving for something that's missing, that missing thing gets a question mark or an X or something, right? So if I go, let's start here. Let's say that the first integer in our list, so this represents the, whoops, sorry about that. This represents the first integer. If the first integer in our list is x for consecutive odd integers, is it safe to say that the one right next to it, you have to add 2 to, just like we did up here? To get from 3 to 5, you add 2. To get from 5 to 7, you add 2. Does that make sense? So if our first integer is x, how would I write 2 more than x right next to it? X plus 2. Good. Okay, so that's the second integer. Sorry, my hand's sticking. Okay, so can someone tell me what the third integer would be? X plus 2 plus 2, which if you combine the 2 plus 2, you get x plus
4.
Perfect. And if we wanted to continue on, we could go on and on and on, right? Clap if you agree with that. All right. So we want to keep this in mind. We're going to be using these relationships as we go through some of our examples today. All right, so how about if we do for consecutive even integers? So can somebody give me the same general sequence? If for odd it was x, x plus 2, x plus 4, what would it be for even? If the first one is x, second one is, Cole? X plus 2, perfect. Third one? X plus 4. It didn't change for the evens, because you're still adding to, there's 2 spaces in between all of them. All right, how about up at the top? If we want to do a general sequence for regular consecutive integers, the first one is x, the second one is, shout it out if you know it. Good, shout it out if you know the next one. Good, and x plus 3. All right, again, keep those in your mind. Questions? Okay, so everybody have this? Can I move it? Yeah? Okay. All right. Before we get to our consecutive integer problems, we're going to go through and do a different type of word problem that just, it requires you to translate from words to math. Okay, so here we go. Can I hear how excited you all are to go through this next problem? Okay. A 12-centimeter piece of tubing. A 12-centimeter piece of tubing is cut into 2 pieces. One piece is 4 centimeters longer than the other. and how long are the pieces? Okay. So everybody go and write that down. We're going to do a diagram to go with this, okay? So diagrams can be really helpful. Let's see. Tubing. Let's say it's black tubing. So that's our tubing, and it is 12 centimeters long. Make sure you can see that. You can. So it's 12 centimeters total. So does that diagram adequately represent what we're doing here? If the black is the tubing? All right, so this is the tubing. Okay, so it's saying that this tubing is cut into 2 pieces. So I'm going to put a cut right there. That make sense? Yes? Okay, this is the first piece. And this is the second piece. So this is not drawn to scale, so we don't want to necessarily think that this is like scaled adequately. Okay, if we don't know how long the first piece is, clap if you agree that you could substitute in an x for the first piece, if we don't know how long it is. Okay. Then it says on here that the second piece is 4 centimeters longer than the first. So if the first one is x long, what would if this one is 4 centimeters longer than that, how would I represent that using an x and a 4? Olivia?
X plus 4.
Perfect. X plus 4. Everybody give Olivia a round of applause. Nicely done. Okay, so is it safe to say, clap if you agree, that if we add together the first piece and we add it to the second piece, we get the total length of the tubing, which is 12 centimeters. Clap if you agree with that. Okay. So now with that, can somebody take what we designated the first piece to be, what we designated the second piece to be, and substitute them in to give me an algebraic equation? Somebody want to come up to do that? Jiro? Everybody give Jiro a round of applause. Jiro is coming up to the stage. There you go. All right. Jiro's going to show us what it should be.
Okay. So, put x plus 4 equals 12. Right.
Okay, everybody who agrees with Jiro, give him a round of applause. Okay, everybody who disagrees with Jiro? All right, nicely done. Thank you, Jiro. Crystal, tell him what he's won.
What did I win?
Oh my god!
Time for the embarrassing moment.
You have won the knowledge of how to use equations in word
problems.
Oh! Oh, I dropped
Okay,
something. Oh,
sorry.
I dropped the phone. Oh, God.
Okay, so here we go. Nicely done. Now,
Oh, gosh.
these parentheses right now, do they serve any purpose? No, so we can just get rid of them. So, can somebody come up and show us what the next logical step to solving this is? Thane, come on up. Everybody give Thane a round of applause. Come on up, Thane. Thane is making his way to the stage, and Crystal is just reeling with excitement to tell him that he's going to do this correctly. Okay. He is slow motion jogging to the stage. All right, Thane, show us what we do next. Do we need some think music?
She forgot the other bird.
So, clap if you agree. Oh, wait, he's not. Okay, clap if you agree with Thane.
Oh.
Okay, clap if you disagree with Thane. Okay. Oh, you guys are so polite. Okay, Thane, thank you. That was a very valiant effort. Everybody give Thane a round of applause for coming up and trying. Okay. Okay, Tyler, do you want to come up?
I have whiteout.
Yes, I do.
Okay, oh right, we have whiteout up here. Okay, so Tyler's going to come on up. Tyler's going to show us what we should do. fact, I'm going to just pause this for a second so that we can let Tyler a round of applause. Okay, ready? So he's going to solve it for us completely. Ready? Think music.
Oh, and then the divide. I'm done.
All right, clap if you agree with Tyler. Yay! Everybody give Tyler a round of applause. Crystal, tell him what he's won. Oh, he's coming back. He's coming back to the stage, folks.
I've won last.
You have won the knowledge of how to use equations in word problems.
Yeah! Nicely done. Okay. All right. That was not a round of applause, people. Okay. All right. So x equals 4, but it's asking us how long are the pieces. So what do I do with that? What do I do with that? If x equals 4, we're looking for how long the first piece is and the second piece.
You add 4.
That's good. So x represents the length of the first piece. That's what we denoted up in the top. So this is the first piece. And Tyler just said we add 4 to this. You are totally right. How do we know to do that?
Because it's x plus 4.
Good. Up at the very top, the second piece is x plus 4. So the second piece is x plus 4. We just found that x was 4. So we take that and put it in here to get 4 plus 4 equals 8. One thing I want to caution you guys on is to make sure you put units back into the problem. Okay, so we started out with centimeters, so we want to include centimeters in the very end. Okay? Questions? Wasn't that exciting, you guys? Yes! Yay! Okay. Now, on to our... Okay, do we all have that? Can I move it? Now on to our consecutive integer problems. All right, here we go. So if you were paying attention to the whole x plus 1, x plus 2, all of that, these should be really, really easy. All right, so here we go. The sum of 3, so the sum of 3 consecutive odd integers. So pay attention to the fact that they're consecutive odd integers. Is 63. And we want to find the integers. Okay. Consecutive odd integers. Okay. Anybody have any guesses as to where to go with this first? How many people can tell me the general sequence for consecutive odd integers? Clap if you can tell me. I will put a hint up here. Clap if you can tell me the general sequence for consecutive odd integers.
3,
Clap if you can do it. Clap. Okay, this is the general sequence. Okay, so the first integer is x, second one is x plus 2, and the third is x plus 4. We're going to use that. Okay, so the first integer plus the second integer plus the third integer is 63. How do I know to add those together? There's a key word in our word problem that tells us how we can add them. Samantha? Sum. Perfect. The sum of 3 consecutive integers. Sum means add. Whoops, I wrote on my table. Okay, so what do I put in here for the first integer again? X. Good. And how about the second one? Everybody shout it out if you know it.
X.
Good. How about the third one?
X plus 4.
Good. Now, how do I know it's not x, x plus 1, and x plus 2? Because it's odd. Perfect. And you have to add 2 to each previous term to get the next one. Okay, so do these parentheses make a difference?
Yes. No.
Do they? I can just take them off. So everybody be thinking right now about how we would go about solving this for our integers. Or at least one of them. And raise your hand if you would like to come up and show how to do it.
I've already went up.
Okay, Deanna, do you want to describe how to do it? Good. Combine like integers. So combine 2 plus 4 gives us how much? 6. Okay, are there any other clap if you see any other like terms in this sentence that we can combine? clap if you see any other like terms. Okay, raise your hand if you'd like to tell me the other like terms to combine in this sentence. Rebecca. X. So we have an X here, 2 X's. How many total? 3. So we end up with 3X plus 6 equals 63. Okay, clap if you can tell me what the next step in the solution is. Clap if you cannot tell me the next step in the solution. Clap if you just chose not to clap. Anybody? Okay, so raise your hand if you would like to tell me what the next step is. Shugi.
You subtract 6.
Perfect.
From 63 as well.
Perfect. So
Then you should get 57.
excellent. Okay. Who can tell me the next step? Okay, Alan?
Divide by 3.
Divide by 3. X equals 19. But again, we are not just solving for x. X represents the first integer, but we also need the second and third. So can someone tell me how I would use the first integer to find the second and third? Let's see. Shugi.
You would plug in x to where all the x's were, so it would be 19, and then 19 plus 2, which is 21, and then 19 plus 4 is 23.
Perfect. So 19 plus 2, 21. 19 plus 4, 23. So our 3 consecutive integers are 19. Whoa, I'm off the page. 19, 21, and 23. Okay, give yourselves a round of applause. That was awesome. Okay, we have one last problem, and one lucky contestant is going to get the mother of all prizes.
Aww.
So, you all ready?
Yeah.
Are you ready for this next problem?
Oh,
Yeah.
We're going to go to a little break in just a second, but I want to put the problem up so our viewers at home can try this out with our studio audience. So here we go. The product of 6 and 9 times a number is the same as the difference of 10 times a number and 2.
Miss Meller, did you write difference in capital letters on purpose?
I did.
Oh
In
my
fact, I
gosh.
write all of my things, all of my words in capital letters. Thank you for asking, Crystal. I write all of my words in capitals. That was an engineering thing. If you look at all plans, all capitals. So it's just stuck with me for the last 6 years. Okay, so then what is the number? Okay, so we're going to take a little break. We will be back shortly to solve this problem. Yay!
Snapshot.
We are back. All right, we have our final contestant of the day, Shugi, coming up to show us how to solve this problem. Everybody give Shugi a round of applause. Okay, let's. Nope. Okay, cool. Cue pink music. Ready?
Isn't it annoying?
Science.
All right. Clap if you agree with Shugi. Yay! All right. Crystal, tell her what she's won. Crystal's making her way to the stage.
You have won the knowledge of how to use equations in word problems.
Oh my god.
Oh my
All right. Everybody give them a round of applause. Yay. All right. Any questions? Make sure I write your homework up here this time. Okay, so you guys are working on homework number 7. It is page 69, numbers 2, 4, 9 to 12, and 28 to 36. Okay, until next time.